Welcome to the 94th lecture of Digital Electronics. So in lecture number 91, 92, 93, we are dealing with conversion of flip-flops. So with this lecture we are coming into the last end of conversion of flip-flops topic. So in this lecture we are going to convert T flip-flop to SR flip-flop, T flip-flop to JK flip-flop, and T flip-flop to D flip-flop. So first one is T flip-flop to SR flip-flop. Conversion of T flip-flop to SR flip-flop. Or what I can write is realization of SR flip-flop using T flip-flop. Now here what we have is T flip-flop. What we require is SR flip-flop. Okay. Therefore we can write T as a function of S, R and Qn. T should be written as S as a function of S, R and Qn. So let us proceed with it. So here S and R are the inputs. So we are having S, R and Qn. So this is the present state. Next state is Qn plus 1. And what we require is T. Okay. So we are having 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, and last one is 1, 1, 1. So if you are writing the decimal equivalence, it will be like 0, 1, 2, 3, 4, 5, 6 and 7. So let me create Qn plus 1. Set and reset 0. So present state will remain as next state. Reset is 1. So this will be 0, 1 will be changed to 0. Set is 1. So it is 1, 1 will be changed to 1. If S and R both are equal to 1, it becomes don't care. It becomes don't care. Now check whether toggling has happened. 0 to 0, 0, 1 to 1, 0, 0 to 0, 0, 1 to 0, toggling has happened. 0 to 1, 1, 1 to 1, 0. So now last two are don't care. Last two because the next state is don't care. Now we need to take only up to term number 5. We need to construct only term number 5. Now coming into the K-map, I'm going to form the K-map. Yeah. 1, 2, 3. So we are having S, R and Qn. You need to find the expression for T. So it is 0, 0, 0, 1, 1, 1, 1, 0. S bar, R bar, S bar, R, S R, S R bar. This is 0, 1. This is Qn bar and Qn. 0, 1, 2, 3, 4, 5, 6 and 7. So let us move forward. So 0, 1, 2, 3 it is 0, 0, 0, 0, 1, 2 it is 0, 3 it is 1, 4 it is 1, 5 it is 0, 6 and 7 are don't case. 6 and 7 are don't case. Now how will you club? That is the next question. You can club like this. You can club in this pattern. So you can club these two. If you are clubbing these two, what do you get? You will get SQN bar. If you are clubbing these two, what do you get? You will get R Qn. Therefore, we can get T is equal to SQN bar or R Qn. SQN bar or R Qn. So I am going to realize this. So I am having a T flip-flop, Qn bar. That is the clock. So here what is T? T is SQN bar. So S and R is there. S, Q n bar. S, Q n bar or R, Q n. So there is an OR gate. Here other having is R, Q n. Yeah. Here you will get T. That is SR flip-flop is realized using T flip-flop. Here SR flip-flop is realized using T flip-flop. Next one is conversion of T flip-flop to JK flip-flop, or realization of JK flip-flop using T flip-flop. So here what you are having is T flip-flop. What you require is JK flip-flop. Therefore you need to write T as a function of J, K and Qn. So here the inputs are J and K. JK, and you can have Qn also. So Qn is the present state, Qn plus 1 is the next state, and you need to find T. So it is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. If both are 0, if J and K is 0, it is 0, 1. Here it is reset. So 0, 0. Here it is set. It is 1, 1. So if J and K both are equal to 1, it is toggle. So it is 0 becomes 1, 1 becomes 0. So if you are writing the decimal equivalence, it will be up to Qn. So it is 0, 1, 2, 3, 4, 5, 6 and 7. Now coming into T, 0, 0, it is 0, 1, 1, it is 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 0, that is 1. Now I am going to draw the K-map. 1, 2, 3. Here what we are having is JK and Qn. 0, 0, 0, 1, 1, 1, 1, 0. This J bar, K bar, J bar K, JK, J K bar. 0, 1, that is Qn bar and Qn. 0, 1, 2, 3, 4, 5, 6 and 7. Now coming into T, 0, 1, 2, 3, it is 0, 1, 2, it is 0, 0, 0, 0, 1, 2. 3 and 4 it is 1, 3 and 4 is 1, 5, 6, 7, 0, 1, 1, 0, 1, 1. Now I am going to club the factors. So how will you club? You can club these two. If you are clubbing these two, what will you get? Which is common? K and Qn. K, Qn is common. If you are clubbing these two, which is common? J, Qn bar. J, Qn bar is common. Therefore what we can write? Therefore we can write T is equal to J Qn bar or K Qn. T is equal to J Qn bar. Yeah. J Qn bar or K Qn. Okay. Now coming into the logic circuit. Here what we are having is, we are having a T flip-flop. Qn bar. Here what we have is the clock. So what is T? T is J Qn bar. When J as input, K as input. J Qn bar or K Qn, right? Or K Qn. So you are having K So here you should have an OR gate. So that gives. Okay. So this is how you are realizing JK flip-flop using T flip-flop. Now the last conversion is conversion of T to D, right? So we have converted T to SR, T to JK, and the last conversion is conversion of T flip-flop to D flip-flop. Or what you can write is realization of D flip-flop using T flip-flop. Realization of D flip-flop using T flip-flop. Okay. So how do you proceed with it? What you are having? What you are having is T flip-flop, and what you require? What you require is D flip-flop. That is you should write D. You should write T as a function of D and Qn. So write T as a function of D and Qn. Now coming into the input. Input is D. Here we are having Qn. This is Qn plus 1. And here what we are having is T. So we are having 0, 0, 0, 0, 1, 1, 0, 1, 1. Okay. So what is D? D is basically Qn plus 1. So you can write 0, 0, 1, 1. D is basically Qn plus 1. So you can write 0, 0, 1, 1. Right. Okay. So now how do you check for toggle? Toggle is if present state is equal to next state, the value of toggle is 0. Otherwise the value of toggle is 1. So 0 to 0, 0. 1 to 0, it is 1. 0 to 1, it is 1. 1 to 1, it is 0. Now you need to write the expression for T in terms of D and Qn. So you can write directly. What is it? T is 1 here. So you can write this D bar Qn or D Qn bar. So T you can write it as D bar Qn or D Qn bar. That we can write it as D XOR Qn. This D XOR Qn. Therefore, how to draw the circuit? You are having a T flip-flop. There is a clock there. D is the input. Qn bar, and you can have the XOR gate. That is okay. Now I have realized a D flip-flop using T flip-flop. So to wrap up this lecture, here in this lecture what I have done, we have converted T flip-flop into SR flip-flop. Then we have converted T flip-flop into JK flip-flop, and the last part we have converted T flip-flop to D flip-flop. Thank you.